Hi everyone, this is Navya and welcome to my AgroVision code walkthrough. Uh, this has been my main focus this semester and I'm really excited to show you how everything works behind the scenes. So AgroVision is my attempt to bring smart irrigation into a simple practical prototype. So we take IoT style environmental data and then train a machine learning model and then provide irrigation recommendation through a clean interactive dashboard. So in this walkthrough, I'm going to take you through the full pipeline, data simulation, model training, and model loading on the dashboard. So now let's go step by step. Before we jump into the code, let me quickly show the structure. Let me open my Visual Studio Code, that is VS Code. So this is my project folder in VS Code. I kept very organized that each part of the pipeline leaves its own layer. You can see it is an app, data, docs, models, and scripts, stats, readme.md, requirements, txt. So first, oh, I have four layers as I said earlier. So in this scripts, I have two layers. This is a simulate data.py pretended to be our IoT sensors, and the one more is train baseline py. So this will trains the machine learning model here, and we have a few more here. Model.py, this loads saved models cleanly, and this is the main.py. As many of you know that this is the main heart of the my application. This is the streamlit dashboard. So the flow uh, is super simple, like generate data, then it will train the model and save the model, then dashboard loads the model and get predictions. This is very simple and super clean. Okay, so now let's explore each file. As I said, I have four layers. So first, let me talk about the scripts. In this, let me talk about the simulate data.py. So you, as of now, I don't have access to real IoT hardware. So I built a script that behaves like one. Inside this gen series, it will generate hourly environmental data. First, I imported all the things I need and data for pandas and numpy for data, and date, time, everything I imported. So then inside this gen series, it will generate hourly environmental data. So here we have temperature, humidity, rainfall, and wind speed. So temperature always follows. It is climate patterns, and humidity also, like it will fluctuate by the weather conditions, and rainfall maybe happens occasionally sometimes. Wind speed is a nice form of normal distribution. Now let me talk about the interesting part is soil moisture. So I simulated using a small evaporation formula. So it is our formula, ET0 equal to max 0.01. It is a formula for evaporation formula. And this kind of models how the soil loses water due to heat and wind. So this will give that when it rains, moisture goes up. Otherwise, that ETO formula pulls it down. So here I generated two fields, one with the one with the loam soil and the under with sandy soil. Different soil, you know, the different soil types retain water differently, which help the model run. So finally I compute irrigation need. If soil moisturizer is low, then it will like water needed is high. If soil moisture is high, water needed is low. I save everything into data raw simulated data. So simulated.csv, that is what I need to run my app. This will run the data type like the file type should be the .csv. This is so it will become my training database. From here I got what I need to run the application, that is simulated.csv. Okay, I got it from here. Next, let's look how I train the actual machine learning model from train baseline.py. So here is it. I load the simulated CSV and extract the features. So as I said here, we got simulated data from here. Then I am loading that CSV and extract the feature what I need here. So the few features are I'll tell you the features here. This is our soil moisture, temperature, humidity, rainfall, wind, and also soil type and crop stage. Okay, these all the features we need. Here the label is how much water is needed in the 24 hours. Okay, I took the how much water it was needed in 24 hours. So since I have both numerical and categorical data, this is the numerical feature and categorical feature. So I created the pre-processing pipeline. So numerical stand for standard scalar and categorical gives you the one hot encoder. Then I attach a simple linear regression. This is my baseline model. The idea was kept it interpretable and lightweight. So here is the linear regression model, and then after training I evaluate using MAE, mean absolute error, and R square values. This is all about machine learning. So mean absolute error and R square values are the most important here. And finally save the model as I saved the model as here models slash baseline dot joblib. Here this will save like this. Okay, and this is what the dashboard uses. This is the one dashboard uses after running the application. So next is the model.py. This file is tiny but super useful. Yeah, as you can see, this is so tiny, and this is the super useful feature I use. Instead of loading the model every time I need a prediction, I use lazy loading. So model equal to none, then first time model load is called it loads the joblib file. If it is calls, it loads the joblib file. Then every call after that reuses the same loaded model, so that I use this. And this makes the dashboard faster and avoid any unnecessary reads. So my dashboard will run as I need. And predict is a simple wrapper around model predict, nothing fancy here.